Hello, Calculus, and welcome to Chapter 4. So you should have your new note section out. I'm pretty sure it's probably gray. And it should be labeled Chapter 4, Calculating the Derivative. All right, so we've done some derivatives already, and some of these rules you've already known. We just haven't given them a name. So now we will give those the name so you actually know what you're doing and continue on and find some marginal profit and revenue at the end. Okay, let's go. All right, we're going to talk about a few techniques for calculating derivatives. We're going to do different notations because notations can be tricky. All right, so there's actually 4 different ways to write a derivative, and you need to understand all 4, so no matter which way you see, you're good. I know I usually use the prime method because that's what I grew up with, but there are others. We're going to talk about the constant rule, the power rule. Both of those you've already used. The derivative of a constant, the sum and difference. Then we're going to calculate marginal revenue and marginal profit. Okay, so when we're going down here, these are the 4 different ways to write a derivative. This is the one I generally use. F prime of x means the derivative of x. This also means derivative of y with respect to x is how that's read. This one's read the derivative of the function, so you have to write out the original with respect to x. This is also the derivative with respect to x of the function. All 4 mean the exact same thing. So let me demonstrate. Our original function is 2x cubed plus 4x. Okay, this is the way I generally write it. So we have the derivative of x, which is just 6x squared plus 4. Okay, it can also be written the derivative of y with respect to x, another very common one. Also 6x squared plus 4. Now, if we're going to write it without these 2, if I say the derivative, I have to put the function here. So the derivative of the function with respect to x, 6x squared plus 4. The next way is the derivative with respect to x of the function. Also, the original must be written out. All of those equal the same thing because they are the same thing. Okay, pause and try yours. All 4 notations is what I want written out here. Okay, these are the 4 you should have come up with. The first 2 I wrote in blue because those are the ones we use quite often, or we have been. So we have h prime of x equals 15x squared minus 6x. Your second notation is the derivative of y with respect to x, 15x squared minus 6x. Next one is read the derivative of your original function, has to be in here, with respect to x, giving you the same answer. The last, the derivative with respect to x of your original function. All of those mean the same thing, so they should not throw you when you see them written differently. First one we've already used. It's just called the constant rule. What that means is when you take the derivative of the number, the answer is 0, no matter what the number is. So if I give you f of x is 9, then its derivative is 0. Okay, do yours. I use different notation here. So the derivative with respect to t, because this was t, of f of t is 0, because the derivative of pi is 0. Now the derivative of y with respect to x is, of course, this is just 9, also 0 again. Just practicing writing your different notations is what we were really doing there. Okay, a power rule, another one that we've already done. You've actually figured this one out already, but just so you understand what you're doing or why it works. So you take the derivative of the function. So d of y over d of x is what this is saying. You take n, so you bring down your exponent, and you reduce it by 1, which you've already done. So this is x to the first. Reducing by 1 gives me 1, right? Because there's no x's left. This in here was 2x to the first. This one, you brought the 3 down, subtracted 1, 3x squared, 4x cubed. This one was a little trickier, remember? So we had negative 1x to the negative second, then we rewrote putting the negative exponent in the denominator. Okay, bringing down the 1/2. Now when you subtract the 1, that was x to the negative 1/2, which meant he went in the denominator. So nothing we haven't done, just putting a name to it. This is known as your power rule. All right? So this one here, so we do the derivative of x is equal to 6x, bring down your 6, subtract 1 to the 5th. Remember this one, in order to start it, we have to rewrite our function. So that's f of x equals x to the negative 2/3. Let's write our derivative differently this time. Let's do the derivative of y with respect to x, just a different notation. So we bring down the negative 2/3. Now we have to subtract 1 from here. So when you subtract the 1, remember you have to have a common denominator. So that's really negative 5/3. Okay, this belongs in the denominator. So the negative 2 is in the numerator. The 3x to the 5/3 is in the denominator, and I am not going to make you rationalize that. So that is good as is. Next one. You've actually done this one already too. It's the constant times the derivative g of x, but we've always taken a shortcut. So technically what this means, like if we were going to do all of our work, we would say that is 5 times the derivative of x squared, which is 2x. So, which means the derivative of x is equal to 10x. The shortcut we've always done is we take the 2 times the 5, which is this rule. So it's constant times a function, and then we reduce our exponent. All right, try yours. Okay, first thing you should have done is rewritten. So this is really 3x to the negative 2/3. Now, when you're finding your derivative, let's write it dy over dx this time. We know we take the negative 2/3 times the 3, which is negative 2, times x, subtract your 1 to the negative 5/3 power. So your final answer should have been negative 2 over x to the 5/3 power. I hope you did well. And I hope you didn't forget your negative. Okay, next one. Whoops. The sum or difference rule. Okay, all this means is that if I have 2 functions, I can do them all individually, which we have also done. So right here, when we're doing the derivative of this, let's just do h prime of t this time. We know we do this one, then this one, then this one, then this one, right? We do them all individually. So this became negative 6t. This one, before we did it, we would have rewritten him t to the 1/2 power. So now we're going to multiply, which gives us t, but now it's to the negative 1/2 power. This one here we would have rewritten 5 times t to the negative 4. So we would have gotten a negative 20 t to the negative 5th, and derivative of negative 7 is 0. Now we have to rewrite all of these using or moving the negative exponents to the denominator. So negative 6t is fine. T here needs to go to the denominator, so it's 1 over t to the 1/2 power, minus the 20 stays, but the t to the negative 5 goes to the denominator. Okay, pause and do yours. Okay, so here when you did this one, so we really have 5t cubed minus 4t to the 1/3 plus 8. So now your derivative of k with respect to t is equal to, multiplied and subtracted, 15t squared minus 4/3, because you multiply these two, right? T to the negative 2/3, so we got some work to do with that one. Derivative of 8 is just 0. So now we need to move this guy to the denominator. So your final answer should have been 15t squared minus 4 over 3 is in the denominator, and so is t to the 2/3. I hope you did a great job. All right, next. Marginal cost. All right, whenever you see this word marginal, be careful because it doesn't always say that. It means find the derivative. So when it says marginal, marginal cost, marginal revenue, marginal profit, all marginals mean first derivative. So we are going to give you your cost function. So this is in hundreds of dollars to produce thousands of barrels. Kind of important at the end of Pepsi. This is my cost function. I want to find the marginal cost at x equals 5. So to find the marginal cost, we take the derivative of c. So we've got 8x plus 100. 500 cancels out. To find it at 5, I plug in 5, and we get 140. What this means, because remember we're starting at hundreds of dollars, thousands of barrels. After 5,000 barrels, because I plugged in 5 for x, are produced the approximate cost to produce the next 1,000 barrels, because we are in thousands up here, will be 140. Okay, that's silly to say that, right? Correct? So we add our 2 zeros on in. It will cost me $14,000 to produce the next $1,000 barrels of Pepsi. Actual is when we take C of 6 minus C of 5. So we plug in 6 to the original minus 5 into the original. We get 144. Add your 2 zeros. So 14,400. So our marginal and our actual are very close. So it's a great way to estimate. Okay, what is the marginal cost at 30? So pause and do your work. Okay, when you found your marginal cost, all you had to do was plug 30 into, we had already calculated my derivative, and you've got 3,400. Actual cost was C of 31 minus C of 30, because you're finding the next 1,000 is what you're looking for. You plug in the 31 minus the 30, and you get 34,400. So it's very close. Again, a good estimate. Quick ways to find answers. Okay, now we're calculating marginal revenue. Again, marginal meaning we're going to have to find a derivative. All right, we know demand function relates number of units Q of the consumer willing to pay for the price P. So P is always equal to demand, always, it never changes. So if the demand function is P equals, they're going to give this to you, 5,000 minus Q over 25,000. So if this is the demand function, then my revenue is I had to take Q times P. Remember how many sold times the price? So then the price is equal to this. So we just use substitution and plug it in. And this is my current demand, our revenue function. What I did here is I took this and divided it by 25,000 to reduce that to 2Q. And then Q squared divided by 25,000. I just separated out that fraction so we could do the derivative easier. So the marginal revenue, okay, we know the derivative of 2Q is 2. The derivative here is you bring down your 2, so the 2 over 25, and subtract. So here is my marginal revenue function. So now I want to know what this was at 10,000 barrels, our units. So we plug in 10,000 for our Q, and we get 1.2. What that means is the next item sold at sales of 10,000 will produce an additional $1.20 in revenue, which is not bad. So I'm still making $1.20 in revenue. Life is good. Now, just for a visual here, here is our revenue function, right? Here's my demand function. If you look, the demand was $1.60. The revenue was $1.20. So this is good. I am still making a decent amount of money. If you look down here, I no longer make money at 25,000. Now let's compare this to my revenue curve. So you know our revenue is a Q squared, so it's by parabola. At 10,000, I'm making 16. Matches, right? 10,000, 1.6. Over here, my max is at 25. Well, that's when I stop making money, all right? So my max revenue right here, my revenue here is at the most it can be. So that's good information to have, just so you kind of see how those graphs are working together. All right, explore. The demand function is 16 minus 1.25 Q. Find the marginal revenue when Q is 5. All right, pause and try this. All right, I hope you did a great job. Okay, the first thing to remember is that revenue is price times quantity. Our price was given to us up here, 16 minus 1.25 Q. times Q, our Q. Multiply those out. So now to find marginal revenue, you're just taking the first derivative of this function. You got 16 minus 2.5Q. I wanted to find this when Q was 5. So now we plug 5 into our marginal revenue. Okay, when you plug 5 in, you got 3.5. What this means, so on the sixth item produced, because at 5, my next item is $3.50. So the sixth item produced will generate $3.50. Depending on the margin, it could be good or it could be bad. Okay, marginal profit. Same thing, we're going to take derivatives here. So we know profit is revenue minus cost. We're going to give you the cost function is 21 plus 0.25Q. I'm going to give you the revenue function, already done, 2Q minus 1 over 25Q squared. I already talked about these guys. So my profit now is I'm going to take my revenue function right here minus my cost function. Let's combine our like terms here. So 2Q, 0.25Q, or minus 0.25Q, is 1.75Q minus the Q squared minus the 2100. All right, so to find the marginal profit, all we have to do now is take the derivative of this function. So the derivative of 1.75Q is 1.75, multiply by 2, reduce my exponent. I want to know the marginal profit at 15,000. So I'm going to plug 15,000 into my Q, calculate that, and we get 55 cents per unit. Not bad. All right. I think I typed this wrong on yours, so I want you to use the same revenue function. Use this new cost function and calculate the marginal profit for 15,000. So when I say the same revenue function, here I would like you to use the revenue is equal to 2Q minus 1 over the 25,000 Q squared. That's the revenue function you're using. So there's revenue, there's cost, calculate marginal profit. Okay, pause that. All right, I hope you did a great job. So your profit function, you should have taken your revenue function minus your cost function, distributed your negative, combined your like terms. So your final profit function is here. After you do that, you should have taken your derivative of your profit function, giving you 1.7 minus 2 over 25,000 Q. I reduced the 2 over 25,000 to 1 over 125,000. Oop, I think I got too many zeros there. I do. Sorry about that. There we go. All right. After you've reduced that there to 125,000, which I wrote wrong here too. Come on. All right. You should have plugged in your 15,000. So when you plugged in your 15,000, you would have got 0.5, which gives you 50 cents per unit. I hope you did a great job. All right, it's homework time. Good luck. Make sure you post questions if you have any. Have a great day.